Okay, so now I'm going to move on to neutralization reactions and then titrations. So a neutralization reaction is a type of double displacement reaction um, between an acid and a base. So, for example, if we have an acid such as hydrochloric acid, and it reacts with a base such as sodium hydroxide, that is going to result in water, which comes from our hydrogen ion here and our hydroxide ion here, and then also a salt, in this case, NaCl. And then that comes from our chloride ion here, and then our sodium ion here. So neutralization reactions always occur between an acid and a base, and they always result in water in the salt. Now, um, neutralization reactions are important in the context of titrations because um, you are in a titration, you are pretty much performing a neutralization reaction. Now, a titration is a process used to determine the concentration of a solute in a solution that's unknown. So if you go back and watch the videos that Miss Smith put, in that video, the woman has a solution of sodium hydroxide, which is a base, but she doesn't know the concentration of it. So she doesn't know how many moles of sodium hydroxide there are in her solution. So what she does is that she uses a titrant, which is a solution she does know the concentration of. And then since she's trying to find the concentration of a solution that is basic, she is using an acid. So she does know the solution of the acid that she's using. In this case, we'll just say it's like 0 um 0.1 molar solution of hydrochloric acid. So when she's performing the titration, click drawing here, her analyte, the unknown solution, is being reacted with her titrant, the known solution. And then when this is happening, she's basically performing a neutralization reaction. So she's slowly taking that acid and turning it into water. Um, and then once this neutralization reaction has been completed, this is called the equivalence point. So now so now the moles of acid are equal to the moles of base, or in otherwise the solution has neutralized. However, obviously these are very small molecules and you can't really visually see what's going on. So what you use instead is the endpoint. If you go slightly past the equivalence point and you add a little bit more titrant to your solution, you're going to see a quick color change. So instead of the solution being clear, because again, neutralization results in water, most of the times you will see a pink indicator, even though it could technically be any color. And then the solution is going to change color. And then this is telling you that now there is more moles of base than there are acid. And it's telling you that it's a visual indicator that your solution has neutralized or that you've used up all the moles of NO sodium hydroxide that you had. So the endpoint is a visual indicator that you've reached the equivalence point. However, It is a bit past the equivalence point, even though it's still very close. Okay. And if you don't still really understand the concept of using a known concentration to find an unknown concentration, it will make a bit more sense when I go into explaining how you do the calculations or like an application-based titration problem. Um, but don't worry too much about it because obviously you're not being um assessed in like a lab. It's not like a PBA. You're just gonna have like multiple choice um questions, and you'll kind of just need a general concept, so you should be fine. Okay, now moving on to the actual calculations with a titration based problem. I'm going to be using question 25 from the study guide if you want to go look at that yourself. So in this question, it's saying using a titration calculation, what is the molarity of hyd phosphoric acid if 15 milliliters is completely neutralized by 38.5 milliliters of 0.15 um of a zero point 0.5 molar solution of sodium hydroxide. So first what you're going to want to do is obviously write the neutralization reaction for the specific problem. So we have phosphoric acid and sodium hydroxide. So phosphoric acid. Also, remember to still know your polyatomic ions, know your solubility rules, all that. And obviously, naming chemical compounds, those are still going to be on the test. I'm going to go ahead and balance that. It's just a 3 on the water and then a 3 on the sodium hydroxide. Okay, so in this scenario, we know that our titrant, the solution that we do know the concentration of is sodium hydroxide. And then we also know that the molarity of that solution was 0.150. And that's just sig figs, obviously. Okay. And then we do know that our analyte, the solution that we don't know the concentration of, was phosphoric acid. And then of the solution, um, we had 15 milliliters of it. So we know the volume, but we don't know the concentration. However, we do know that it took 38.5 milliliters of the titrant to neutralize this phosphoric acid in our titration experiment. So with this known information, we can calculate the molarity of the solution with the phosphoric acid. And then the formula for this is um, the molarity of the acid times the volume of the acid over the moles of acid, and the moles is represented by N sub A or B, depending on if it's the acid or base, is equal to the moles of base times the moles times the volume of base um over the moles of base. And then from there you kind of just go ahead and plug everything in. Now, just to clarify, when looking at N sub A or N sub B, you're going to be looking at the molar coefficients from your initial chemical equation. So in this case, we would be writing um 15.0 milliliters of our acid. Um, don't know the molarity. That's what we're trying to find. And then we had 1 mole of that in our initial equation, like right here. That means one. And then 38.5 milliliters of our base. And then the concentration of that was 0.15. Kind of leaving out sig figs and stuff here, but again, make sure you pay attention to that on the test. And then we had 3 moles of this. And then this kind of just has to do with for every 1 mole of phosphoric acid, you need 3 moles of sodium hydroxide to react with it to neutralize. So that's where that comes in. And then from there, you kind of just do the algebra, and then you should end with the molarity of the acid being 0.128 molar. So yeah, that's pretty much all you have to know for titrations. And then other than titrations, know a couple other examples of indicators. I'll just write them out real quick. So you obviously have litmus paper, red being for acid, blue being for base. You have your red cabbage juice. If you guys have taken AB Bio, we did an experiment with this in class. Um, and then there is also another chemical that I'm not very good at pronouncing. But we'll try. Phenolphthalein. So those are the three main ones we went over in class, but just do know that indicators are pretty much like naturally occurring in nature as well. Just might be a concept that comes up.